Первый спикер у нас из Tesla, Engineering Project Manager, Mohib Jafri. Доклад называется «How Startups Build Tech, Tesla Autopilot and Seed Labs». Hi, Mohib. How it's going?
Going great, Sergey. Good to see you.
What's time in Boston now?
It is the right hour of 12 a.m. here, so having a great nighttime visit to see you all in homes.
Such a huge difference. It's 11 a.m. here. Thank you for being with us despite such a late evening. So, let's start. Готовьте свои вопросы в Телеграме.
Great, so I'll go ahead and share my screen. Yeah, so hi everyone. My name is Mohib Jafri, and I think the layout of today is going to be just a few minutes of slides, say 15 minutes, and then we'll go into maybe some discussion. Sergey has some pretty cool questions I hear about some of my background and some of the work that I've done. But for now, my name is Mohib Jafri, and we're going to talk a little bit about how startups build technology. Three sort of particular areas that I want to talk about are the concepts of validated learning, innovation management, and finally, some concepts around different tools that we like to use at Tesla and at my startup company in the meantime. A little bit of background on myself, because I hear that's pretty fun to talk about. So I got my undergraduate degree at Harvard University. I studied electrical engineering and computer engineering with a minor from the Massachusetts Institute of Technology, MIT, in entrepreneurial innovation and management. During my time at Harvard, I got to run a few really cool events and conferences. One in particular was VHAX, and that was the first ever hackathon held at the Vatican. So we actually partnered with the Catholic Church and through an event raised a bunch of money, flew about 120 folks from all around the world, designers, engineers, product builders, and we created a hackathon for social impact. That was a really cool experience to have done. Later, I got to work at a startup called Tembo Education. Tembo right now is touching nearly 50,000 children in developing countries by delivering a text message-based education system directly to the phones of the parents in some of the most remote villages in places like sub-Saharan Africa, India, among other places. And I got to work a lot on their machine learning pipelines over there, making a more personalized education experience. I very quickly started to get more interested in hardware, and so decided to do a brief stint at Boeing Space. Over there, I was part of the PhantomWorks division, where we worked on advanced military and space prototyping. If y'all are familiar with FPGAs, that's sort of a lot of the programming type of hardware design that I worked on there. And then later on, I started to get more into startups, kind of going back to my roots. And I joined this startup called Gravity. And as you can see, they make jet suits, plain and simple, a bunch of jet engines strapped to a human being, and you're flying around in all 360 degrees. That was an incredibly fun experience. And then came the past 2 years, which have certainly been no short of interesting. I started off the year doing a brief stint in the Gigafactory of Tesla, where I worked primarily as a manufacturing controls engineer. So we were just launching the brand new Model Y and had to 4x, 5x our production of motors and batteries to meet the Model Y's production ramp up schedule. And so a lot of cool automation stuff going there, but really where I've been cutting my teeth at has been at Tesla Autopilot. Over there, I'm a hardware program manager, and we've shipped some really cool stuff. I'm sure many of us are aware of it. In the past year, you've seen huge overhauls in terms of the camera architecture, terms of the radar systems. We shipped full self-driving, and there's plenty of more stuff to come. In parallel, I've also been working on a few other cool businesses. So first was sort of in the relationship management kind of space. I teamed up with a few buddies and we created a delightful personal relationship manager called Iris. And that pivoted into a few different companies, eventually ended up with this really cool product that I'm working on right now called Seed Labs. And essentially our goal is to make philanthropy for the 99%. What if donating to people and causes that you cared about was as easy as buying something on Amazon or whatever the equivalent is in Russia? And so that's what I've been working on in my past. And today I'd like to sort of talk about how at all these different startups, at software startups, at hardware startups, startups of just myself and my co-founder, or as large as something like Tesla, where we have a market capitalization in the hundreds of billions, how there's a lot of common traits that sort of tie them all together. I think what I'd really like to show in this talk right now is give a few points for the audience to have some cool questions maybe to talk about, but also just to show how a lot of what we do at small companies and large companies is really the same thing if you think about it. And so it's sort of to give you that theoretical backing. I wanted to begin with this concept of validated learning. So validated learning is really what at startups we're all focused on doing. It is finding a way to, with real data, uncover some truth about some thing about the universe. It really is as open as that. It is, can you have data? Can you have launched something that proves something fundamental or proves something contrarian, something interesting about the business or the nature of people or the nature of business? And how we achieve validated learning is a very difficult question. And really the guiding question that I think of whenever I'm launching a new product is, how do we create a system? As an engineering project manager, that's really what I'm good at, is creating systems. How do we create systems that get to validated learning more frequently and more intensely? And so validated learning kind of has a bit of a feedback loop that kind of goes on. And the feedback loop is called the build, measure, learn feedback loop. And I wanted to kind of touch upon a few parts of the build, measure, learn feedback loop. I'm sure many of us have heard about what's called the minimum viable product, which is sort of what the user touches. What is that physical product that you can get out of the door as fast as humanly possible? But oftentimes we don't talk about the minimum viable program. And the minimum viable program is really the system that you've created to get to the moment where a user finally gets to touch the product that you have built. And this is really important of a distinction, because the product is pretty narrow in scope. It is a product, but the program is such a more complex system that I would love to tease apart. We don't have too much time, so 3 big parts of the minimum viable program that I think a lot of folks creating teams and building new products tend to forget is, first, something called the go-to-market strategy. The question here is, we're trying to measure our TAM, our total addressable market. How many customers might we have? How many people might be interested in what we're building? And the answer there is marketing, sales, and distribution. How do you test that in as lean of a way as possible? Do you need to spend millions on Google advertisements? Or do you need to go to a conference where everybody there would be an amazing customer of you? Second thing that I like to think about in the MVP is the team. Overhead is a huge question that you don't want to spend too much of when you're starting a brand new product. And so I really like to ask, who are the fewest amount of people with the most amount of versatility that I can hire to have a kick-ass team to ship a product? We want to keep that count as low as possible. And then, of course, there's the finance part of it. Businesses are here to make money, and you don't want to burn too much money. And so seeing sort of your business and the launch of your first MVP through the eyes of a financial lens is really important. And so once you're thinking about building your minimum viable program, there's a concept of measuring, which is, you've launched a product. How do you know that the product is working or not? And typically what we think about is KPIs, key performance indicators. And I have a few rules of thumbs on those. So first is pick one true north. This is the one metric that if it goes up and to the right, if it increases over time, that's 2 thumbs up for everybody. The second one is avoid vanity metrics. I think we tend to find numbers that correlate to good traction, but don't actually mean something fundamental. For example, if you have a bunch of people visiting a website, that's a great thing. But if nobody's converting to a sale on your website, if that's what you're looking for, number of web views is really just a vanity metric. And third, and probably the thing that really should stick home, is that every single MVP needs to record data. I think too many times have I seen teams that have launched products with no sensors out in the wild. So how do we set a KPI? This is a super kind of broad concept. First things first is, we don't want to be too creative here. You don't have to be out of the box here. The way you get there is out of the box. The KPI itself doesn't have to be too crazy and out of the box. And here's a small example. So at Tesla Autopilot, we have many different things that we're trying to achieve. But one of our biggest ones and one of our most paramount ones is to have the most amount of autopilot miles driven without disengagement. That is a really good metric because the more people trust us, the less disengagement there is. But that's not the only thing we wake up and try to do, right? Our major KPI is not actionable on a day-to-day basis when a team has to think about what we do for the day. And so we have sort of a smaller set of other KPIs. We have sort of the material bill of materials. So how much does our car cost and how can we keep that lower? So we can increase the number of vehicles on the road by decreasing the price of the vehicle. How do we manufacture these at scale? How do we make sure that the takt time is super, super low? And then of course, how many people are buying full self-driving, which is getting more expensive by the day. And so once you have these sensors out in the wild, you ask the question of how do we learn from it? And the real key question that I try to ask here is, what is our runway? It is how many experiments can we push out into the open before we run out of time or money or willpower or all of the above. And typically what I found really much more successful in most of my product launches, both at Tesla and at my company, has been many experiments to slightly test the market. Have always been great ways to learn rather than one big experiment. Gives you a lot more runway, relatively speaking. I wanted to talk about this concept called innovation management. And this is borrowed from an amazing book called Loon Shots by Safi Bahcall. The concept here is, we try to think about teams in terms of loon shots and franchises, or artists and soldiers. Artists are the folks that are thinking about how is your company going to achieve something great in the next 10 years. And your soldiers are the ones that are doing real business today and giving us the money, the capital to be able to fund the artist for the dream of the future. And the important thing to note here is, A, you need to love them equally. No successful company survives without both of them. And then also it's to recognize that they thrive in very, very different environments. If you tell a soldier, if you tell a business person, yeah, ship the product whenever, make money whenever, you're not going to make money. If you tell an artist, make 3 good ideas per hour every day for 10 hours, that's just not how ideas are built. And so really the goal that I think about in terms of these soldiers on one side and the artists on the other is that our goal as managers is to manage what's called the dynamic equilibrium, if you will, the exchange of ideas between the two, between the franchises and the loon shots that ultimately determine the big dreams of the future. And finally, I want to touch upon some fun stuff. Tooling, everybody loves tooling. I'm a huge productivity nerd myself. And I always have to find myself pulling the brakes because I need to remember that tooling is not an end in and of itself. The goal here is to increase our team's productivity. There are so many awesome productivity tools out there, but the best one is always the one that your team actually uses. And to find out which one your team actually uses, I actually like going the opposite direction than how we like to think of getting the coolest, the most expensive productivity tool out there. There's this concept of Occam's razor, which is a mathematical concept that the simple solution, the most elegant solution, the tightest solution is typically the right one. And so what we typically do to figure out what our Occam's razor productivity tools are at Tesla is we do the bitch work first, pardon my French, but we do the hard work. We do the work that we really want to automate away. As an electrical engineer and computer scientist myself, I love automating things, but you first want to feel the pain. And you'll find that naturally you'll tend towards finding an optimal solution without needing to buy crazy systems or adopt very clunky tools. Some of the awesome ones I like to use are Kanban as a project manager, Gantt charts. Checklists are surprisingly awesome. You'd be surprised at how many things at Tesla we've shipped just by having really thorough checklists. And of course, in code, there is an infinite amount of great stuff. At my own startup, we use Jest and Lint to have a superior developer experience. I'm an IDE person. I hope somebody can fight me over camera and tell me why editors are better, or better yet, why Emacs is better. And generators is also a great thing to use to just increase our developer experience. But again, productivity is the goal here. The productivity tool is simply the means. And with that, with this super sort of wide-ranging kind of what I like to learn about, what I think about startups, how I think about startups, I'd love to give it over to Sergey. Thanks so much for having me, everyone, and I'm looking forward to what questions we have.
Thank you very much. Oh, there is an echo. Okay, it's better now. So thank you very much. Could you please apply all these framework parts to autopilot development? Maybe some examples, because it's more about idea generations and management.
Yeah, so there's actually some really cool concepts of launching an MVP that Tesla has used at scale. So if you think back to where we are right now, which is having launched full self-driving, we have a very complex neural network running on a very intelligently designed autopilot computer on some of the best cameras and radar sensors out there in the market. But actually, the very first thing we shipped were off-the-shelf cameras, were not even that cool of a, it was an NVIDIA internal GPU that we were doing some of our initial compute on. And that was back in, I believe, 2015. Even at the scale of Tesla, this concept of shipping the least amount of things necessary to learn what we need to learn, that was sort of core to the function of how Tesla came to be. We shipped, we knew we couldn't afford hiring an entire team of hardcore thermal engineers and computer designers, but we knew we could get some mechanical engineers and toss a camera in. And we could see if the camera placement was good enough to start kind of training our autopilot computers. And by continuously doing these small improvements over time, you get something awesome, like last year when we launched full self-driving.
Great. So one more question from me, and then probably someone in the auditory will have another question. So it's supposed that 90% of the work on autopilot can be done in 10 years, but the remaining 10% can be done up to 100 years because of a lot of special cases. What do you think about it?
Yeah, so I think Elon has famously said many times that as of 2020, most Teslas are shipping with all of the hardware required to have full self-driving. And I think that really was the 90% here. The final 10%, kind of like we're alluding to these edge cases, that's going to take a long time. And I don't think it's going to take 100 years. I'm hoping it takes less than that because, my stock is not going to show up in 100 years. But I think there's two really cool approaches to how we think about the future of self-driving. There's the Tesla approach, and there's sort of there's a company called OpenAI that has a completely different approach. Tesla's approach is they have the largest fleet over anybody else in the world in terms of electric vehicles with cameras on them. And so Tesla takes a feature for feature approach, which is, how can you solve a particular a particular recognition problem or a particular navigation problem? How do I detect a cone today, a plastic bag tomorrow, a child running across the street another day, so on and so forth? And that's sort of the feature for feature. I think Tesla is eventually going to get there, but there's a totally separate approach, which is what a company like Comma AI does. And Comma AI does sort of a generic deep learning approach, where they say, we generalize the problem to, there are sensors out there like the camera, and actually just the camera, and there are actuators, which is the movement of the steering wheel, the accelerator, and the brake pedal. And everything in the middle is purely a neural network. And the whole question here is just training it properly. And so you kind of see this feature for feature versus pure deep learning route that is trying to complete that 10%. Who's going to win that final 10%? I don't know. I wish I knew. If I knew, I would have my money in one or the other. But these are two approaches that I think the final 10 years are going to play out. The final 10% will play out in.
Okay. So, Olga. So, no, sorry for my Russian. Оля Мальцева, руководитель Академии, Rubius Академия, она поможет задать вопросы. Если у кого-то вопросы в зале или онлайн, вы можете в Telegram писать по вот этому фреймворку, который позволяет быстро тестировать гипотезы и гораздо более comprehensive, всеобъемлющий, чем просто MVP-подход. И, может быть, по будущему автопилотирования.
Там совершенно другой вопрос, Сергей.
Да? Ну, я просто... Hey,
Mohib, so the question from our guys is, how can I get a job at Tesla?
It's very difficult. I think there's a pretty cool lesson to be learned, at least from how I kind of learned how this sort of big tech world kind of works. Early on in my college career, I tried time and time again to get at least an internship at Tesla, get to work under somebody somehow. And it was very difficult. Throwing a resume online is, it's almost like throwing into the nether. You have no idea if someone's going to respond to you. There's no promise. You hope a computer algorithm will pick up your resume. It's very difficult. And the actual truth of how I managed to get into Tesla was I met somebody who referred me to the recruiter there. And I think the lesson that I learned there is that, the world relies so much more on who you know first than what you know. And so, of course you have to be smart when you get to the interview, but to get to the interview, there's so much sort of warm introductions, knowing people involved. And, I think that angers me a lot, that that's how the world works. And so what I've sort of resorted to is my goal is to open the floodgates wide and open. If anybody wants a job at Tesla, wants some way of knowing how to get in, I want to be that door for as many people as possible, just like somebody was for me. So not a crazy helpful answer, but I hope that kind of shows you my thoughts on that.
Thank you. So networking first, right? As we here know. So there one more question for you. Thanks for your speech. So please advise the first simple step to launch a startup from your current point of view.
Yeah. So I have failed many times launching a startup by thinking about, the latest piece of technology that I want to work on, or a particular framework that I had never learned before. I think when I first learned how to use AngularJS, which was a JavaScript framework, I was so excited. I was just ready to build kind of anything. And the moment I built something, I thought, okay, great. I have this product. Who wants it? And how do I put a price tag on it? How do I sell this to as many people as possible? I failed many, many times doing that. I think a lot of people get lucky doing that. There's the Zuckerbergs, Facebooks, things like that in the world where you build the product first and then the people will come. But I think in most cases, actually, it really revolves around talking to customers and finding real pain points that customers have. And I think that taking that approach, at least in terms of building consumer products that people directly are touching, has been much more effective. If I think of the first step that I would do if I was sort of entering a brand new space, trying to build my first startup in a new industry, it is to talk to customers first. And you want to hear it from the horse's mouth. You don't want to imagine what they need. You don't want to think that, oh yeah, they have to need this. But get it from the horse's mouth is my first piece of advice.
Oh, thank you. One more question to you. Are there any ideas of making some changes to current driving rules to make full self-driving more reliable? Are there some things in rules that make a lot of challenge for FSD?
Yeah, there are a ton of different regulations that you kind of got to hop around. Of course, all these views are my own. I am not a legal person at Tesla. I'm an engineer who runs teams and builds products. But a few of the different regulations that definitely are going to have to change. I'll give one in particular. It is it's such a small one. We could talk about driver alertness. We could talk about seat belts and braking and all that stuff. But actually, a really fun one that I got to dive really, really deep into is there are particular laws in the United States around how fast a windshield needs to defog. And so, when you defog the front of your windshield when it's super cloudy, it actually has to meet regulation within a particular number of minutes. And the interesting thing there is there's actually no regulation around how fast a camera looking forward, not a person anymore, but a camera looking forward for self-driving has to defog in. And so, it was a pretty interesting sort of, a bunch of us were left to interpret the law of, how fast do we defog this? Do we treat it, we have to be better than a human, just as good as a human? There's so many interesting places where self-driving, the laws were not made for computers to be driving cars. And I think that was just one very interesting example of regulators are going to have to catch up to technology. Technology is going to have to inform regulators. It'll be this interesting sort of back and forth in the coming years.
So one more question we have here. When building a system or implementing changes, do you test or see how it will work on the fly? So your approach to testing and system-like workflow, of course.
Yeah, so I think at Tesla, we're famously known for the concept of continuous deployment. I think in software, this is something that we're much more comfortable with and much more familiar with. It's, you don't wait for massive sort of 1 month at a time, 1 quarter at a time overhauls of your feature set or bug fixes. Tesla is a very hot fix. You see something wrong, fix it, and the next car is always better than the one before it. I really like that approach because, unlike traditional car manufacturers where they have to wait for every calendar year to introduce new exciting changes or safety features or really anything fun or delightful to the customer, instead of having to wait every single year, Tesla just goes for it. If it makes sense that we can do it right now, let's do it right now. It's definitely a bit difficult to manage, all the different releases happening pretty much simultaneously, but I guess that is the price we pay for rapid deployment. And so, yeah, rapid deployment is what I'm a huge subscriber of.
Thank you. And one little question from me. So are you still working from home or have you returned to the office?
I am working from home as of now. The Bay Area is not the safest place to be working in right now. So, I'll be getting very cozy for the foreseeable future. Hopefully things are looking better, and it looks like things are pretty great in Russia right now. So, if our team moves to Russia, I will be the first to be working in the office.
Thank you very much.
So, yes, I have one more question about the autopilots. Previously, there was the only approach to create an autopilot, a lot of hardware and complicated artificial network and board. But a vehicle alone is limited by its visible area. The more promising approach to create a network of cars which could share the information about the environment and agree on their behavior. What do you think about this approach?
Yeah, so there's some really interesting work being done right now in multi-agent learning. So the concept of if you have a bunch of actors that each have their individual objectives, one car needs to go to another place, another car needs to go to a different destination. If you have sort of coordination of data between the two, you can actually unlock some really interesting optimizations. There's actually a really great TED Talk that is all about this, right? It's if every car could talk to each other, how faster we could move. You could have cars that are nearly bumper to bumper going at 100 kilometers per hour and have zero car accidents because everybody is talking to everybody. I think it's a really promising sort of future. And I think on paper, it is super, super cool. The real question comes into the implementation, right? It is that, you're expecting a critical mass of individuals on the road to have these sort of communicating systems. And that's obviously very expensive. And it's hard to agree that Toyota and Tesla and Honda and Bugatti and Mercedes all have to now talk to each other. That's a bit hard to see in the real politics of how automobiles work. But I actually like to think of this in the way that Elon has spoken a lot about, what it takes really to solve full self-driving. And the thinking here is, when you and I drive a car, probably on the way to this conference, we didn't have to have, explicit communication with every person on the road. In fact, we really just needed our eyes and our ears. And so, the thinking here is if, humans are able to do it with the limited amount of sensors that we have, truly just vision and a few actuators, steering wheel, accelerator, and a brake, then the problem really isn't the sensors from a first principles kind of approach. The problem is the learning approach. It's the computation that we do upon those sensors. And so that's really the approach that I subscribe to a lot. Of course, I'm sure Tesla has other thoughts of it. I'm on the hardware team, which is very different than the software team. But that's sort of my belief that, the issue here is not necessarily the sensors. It's going to be the computation. And that's that final 10% like we talked about earlier today.
Okay.
So, Sergey, do we have time for one more question?
Yes, of course.
So, are you using Jira plugins that Tesla has made for itself? If so, which ones?
Sorry, what plugins?
Jira or Jira. I don't know how you call it there.
Yes. Tesla does use Jira. I think Jira, Confluence, the whole Atlassian sort of suite is pretty awesome to me. I can't think of any terribly interesting plugins off the top of my head. But what I will say is, we found that sort of, especially when working with external suppliers, Jira has always been interesting. There are suppliers that we've worked with in all parts of the world that totally love Jira. And we've had some folks that really just don't care for Jira. Actually, maybe the plugin or the feature that has been most widely adopted is the reply with an email feature. So somebody tags you in a Jira ticket, and instead of having to open Jira, log in, and respond to it there, you could actually just reply in line from your inbox in your email. Weirdly enough, that has actually been the most, I would probably say, the most used feature across my work and a bunch of the suppliers that I'd work with.
Thank you. Actually, we've rolled out recently our Planeway product for team management for Jira, and already about 100 companies use this tool. Probably it would be useful for you as well. So another question, what is the most important soft skill needs to be a good engineer from your point of view?
That's a great question. I would say clarity and thought. This is a really tough one. I think as engineers, we tend to think at 1,000,000 miles a minute. You know, you're solving the next 100 problems ahead. And so the biggest one that I recommend folks work on is, and this is sort of along the lines of when you're doing like a coding interview and you may have to verbally lay out sort of how you're thinking about designing an algorithm. Being able to walk someone through the world that you see is the most valuable thing. I think when you have that sort of level of clarity of the work that you're doing or the picture that you have in your head, when you have that level of clarity to be able to communicate it with others, that is where your work as an engineer gets multiplied. It is where you can inspire another engineer to work with you. It is where, you know, your manager or your team sees sort of the brilliance that you may have inside of you. I think it really is about the clarity and thought that will drive people to be attracted to you and to your ideas, of course.
Yes, same for startup, for the CEOs of startups, because you also need to have very clear thinking. So what else? No questions. Okay. Как удобно.
Can you hear me? No? So another question about startups. What do you think? Is it possible to combine work at startup with something else, like a regular job or university study, or you should be just 100% committed and nothing else?
Yeah, that's a great question. I think I've done a fair share of both. You know, during university, I've founded some companies, some of which have done well and, you know, kind of have their own team, other of which, you know, you'll never even be able to look up online. And, you know, it's very difficult. The way that I kind of see it is, if the product was important enough that, you know, that there'd be enough of a business model, you know, to support a full team, a full business out of it, you know, it's not worth keeping it as a side hustle. In other words, you know, the fear of having an amazing idea and sitting on it as a 5 hours a week kind of project is, it could actualize to something so much bigger if you actually gave it the attention that it needed. With that being said, though, I think there's the reality of the situation is, you know, we can't all just abandon our jobs and go work on crazy startup ideas. I think venture capital is changing that a lot. The way that I sort of see venture capital is, you know, you can raise a very small round, a seed round, a pre-seed round of, you know, a few $100,000, maybe even less than that. And that's able to finance you to go figure out, you know, if there's a business model out of the product that you're building. And so, you know, if you take the money equation out of it, and if you take that out through venture capital, I think that's where, you know, the conviction that you have really is a good correlator to the amount of time that you spend on the project, which I think correlates to the success of the product.
Может быть, есть вопросы на русском, мы поможем с переводом, ребят. Не стесняйтесь.
Да, будет еще такая возможность. Давайте. So actually time's up almost for this speech. So thank you for your exciting speech, and we're looking forward to seeing you driving from Boston to Siberia by Tesla Autopilot sometime. So probably see you next DevPro in person here next year. So thank you. Have a good evening and night.
Thanks, everyone. Take care. Thanks, Sergey. Thanks, DevPro team.
Thank you.